Hello learners, I'm Akash. I completed my BTech from NIT Rourkela in the year 2020 and currently I'm a mathematics teacher. Now let us state and prove addition theorem on probability. Here is the statement. If E1, E2 are any two events of a random experiment and P is a probability function, then P of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. We'll have to prove this. Okay. Now there are basically two cases, okay? There are basically two cases. Case one is when E1 intersection E2 is equal to 5. It's a null set. That means this diagram, okay? This is the diagram. This entire red box is my sample. This entire red box is one part, like it's my total set sample space. And within that, these are my events, E1 and E2. You see, they're not meeting. They're not meeting. They're not intersecting at all. So that's why E1 intersection E2 is nothing but 5. Okay, it's nothing but 5 since they are not meeting. Now, since E1 intersection E2 is 5, it's a null set. What is the probability of E1 of that? It will be 0, right? P of E1 intersection E2 is going to be 0 since they are not intersecting only. P of E1 intersection E2 is going to be 0. Yes. From this, since P of E1 intersection E2 is 0, there is one another theorem which states that P of E1 union E2 is nothing but P of E1 plus P of E2. Now this one I can write it as P of E1 plus P of E2 minus 0. 0 I can add and subtract. Now what is this 0? This 0 in place of this 0 I can write P of E1 intersection E2. In place of this 0 I can write P of E1 intersection E2. That's it. My first part of the proof is done. Like my first case, I could prove that this is valid. This is what I had to prove, and for the case one, I have proved it. Now case two. This will be a bit difficult in the sense of understanding. So please stay with me. Okay? Please stay focused and be with me. Now, when E1 intersection E2 is not null, this is the diagram. See, basically the two circles are meeting. The two events have something in common. Okay, whenever the two events have something in common. Okay. First, understand this diagram. Okay, what is there in this diagram? E1 and E2, like these are meeting. The two events, they have something in common. They have something in common. Okay, and if you'll observe this, just this vertical lines, it is E2. It is just E2 minus E1. I have sorry, it's not E2. It is basically E2 minus E1. Okay? And this this intersection part, like which has vertical and horizontal lines. This intersection part, this is nothing but E1 intersection E2. Okay, it's important to make a diagram. It has marks, so please make the diagram. Like I've just made it with reference to textbook, so you can make it as it is. Now next, you can just make the lines like this, and this vertical lines are nothing but E2 minus E1. What is it? I'll explain as I go through the proof. I'll explain carefully now. Now, what is E1 union E2? Okay, E1 union E2 is nothing but this two circles. Okay, this two circles and this entire intersection part and everything. E1 union E2 is this total thing, whatever is there within the two circles. Fine. Now that is equal to P of E1 plus P of E2 minus P of E1 intersection E2. That's what we need to show. Now, E1 union E2, I can write it as E1 E1 union E2 minus E1. E1 union E2 minus E1. Now what is that? I'm going to draw and show it to see. See, E1 is this. E1 is this circle, okay? This total circle. I know it won't come out nice. Still manage. E1 is this circle. E2 minus E1 means see, whatever is there in E2 from okay, I'll use a different color so that it would be good. Fine. Fine. This much. This is my E2 minus E1. This is my E2 minus E1. This blue part. This entire blue part within the region of the blue part as well. This red part is like E1 and this is E2 minus E1. So this entire E1 union E2, I'm taking it as E1 union E2 minus E1. E1 union E2 minus E1. Okay. This part is this E2 minus E1 and this is this E1. Okay. Now if you observe, when I consider, it is the same thing. Okay. E1 union E2 and E1 union E2 minus E1, it's the same thing. But when I consider it like this, their intersection is null set. Their intersection is null set. You see, in my red region and my blue region, is there any common part? No, right? There is no common part. So that's why, since there is no common part, whenever there is no common part like this, P of E1 union E2, I can write it as P of E1 union of E2 minus E1. As I told you, E1 union E2 is nothing but E1 union E2 minus E1. I can take it. Whenever between these two events there is no common part, so I can directly write it as P of E1 plus P of E2 minus E1. P of E1 plus P of E2 minus E1. That is the major reason why I have written like this. Now next, what is this E2 minus E1? Okay, what is this E2 minus E1? This blue part. Okay, you guys are able to see this blue part. Now this blue part I can write it as something else also. What this blue part I can write it as? This blue part I can write it as, I'll use some other color. Let me take black, I think would be good. Okay, this blue part I can write it as this entire E2, this entire E2. This blue part I can write it as this entire E2 minus this circle, minus this region, minus this region. Okay, minus this region. Fine, minus this region. So E2, that blue part which I showed you previously, this curve sort of thing, this one, this I can write it as entire big black circle minus this another small this black region which I shaded, right? So therefore this big circle is nothing but E2 minus E1 I can write as E2 minus of, and this common black shaded region is nothing but E1 intersection E2. So this one I can write it as E2 minus of E1 intersection E2. Okay, since as I mentioned, since E2 minus E1 is E2 minus of E1 intersection E2, from the figure I explained and showed it to you. Now next, this very important statement, this I can write it as directly P of E2 minus P of E1 intersection E2. Why, you might ask? There is a theorem, it is already proved in the text. See, if you'll observe, E1 intersection E2 is a subset of E2. E1 intersection E2 is a subset of E2. Whenever it is a subset of E2, then P of E2 minus of E1 intersection E2 is going to be P of E2 minus P of E1 intersection E2. Okay, it's already proved. You can just use it as a reference like this. You can just state this reason and say that this is valid, and that's it, right? Our work is done. P of E1 plus P of E2 minus P of E1 intersection E2. Therefore, P of E1 union E2 is nothing but P of E1 plus P of E2 minus P of E1 intersection E2. That's it. Thank you very much for staying with me until here. Hope you like this video solution. It took me a lot of effort to do this. Okay, putting the diagram and like understanding the theorem as it is and like putting it to you so that in a way which you could understand as well as present it in the exam with explanation. So please hit the like button if you found this solution to be useful. Okay, and if this is your first time coming across to my channel, please do subscribe to it. Not just this chapter, I've covered some other chapters as well: quadratic expressions, complex numbers, and theory of equations. You can just go to my channel and check out the playlist. You should be able to find out some more questions related to them. Okay, thank you very much. Once again, I'm Akash. I completed my BTech from NIT Rourkela in the year 2020, and currently I'm a mathematics teacher.